Hello everyone. Today we are going to discuss about binomial distribution and Poisson distribution problems in this session. First of all, let us know what binomial distribution is. Here is the definition for the binomial distribution, which is suggesting that it is a discrete distribution expression which considers the success or failures. First, first of all, let us know about binomial distribution. A binomial distribution. First of all, if we consider a random variable R set to the 5 follow the binomial distribution, if it satisfies the max mass function P of x equals to R, where R is the number of successes and N is the number of trials. That means when we use N trials and R is the successful chances we are getting by doing the N trials. And here is the formula. It suggests that yeah, R should be a finite integer. Here, if we see it is the mean function, mean formula, and P is the where here P is the probability of success and Q is the probability of failure. Let's go into the problems. Here, if we consider the problem, the problem starts with out of 800 families, each one of them have 5 children. Here we expected to calculate the probability of having 3 boys out of five children of 800 families. And second is calculating the probability of having 2 girls out of 5 children for 800 families. And third is asking about the 2 or 3 boys for 800 families, which has 5 children. First of all, we will write the given where the total frequency is denoted by capital N, 800 families, 800 families. We are using, that is, we are considering the 5 children as trains. So therefore, small n equals to 5. P of success, here we are getting the children, right? And from the sum, we can assume that P of success and failure have equal probabilities. From the first sum, we should calculate that out of 800 families having 5 children, how many families does have 3 boys out of 5 children? So P of x equals to 3. From the formula NCR P power R Q power n minus R. Substitute, just plugging the values, we will get the 5 by 16 probability for 3 children. So we should expect it to calculate it is the probability for one family, but we are expected to calculate for 800 families, right? 800 families. So the number of families having the 3 children is 250. And we are going to calculate exactly 5 girls. Exactly 5 girls. Here not the two girls. From the sum it is 5. So we are expected to calculate the probability for 5 girls out of 5 children for 800 families. If we are going to calculate for 5 girls, that is no boy is present in those 5 children, right? So we are expected to calculate the success function we are taking as here boys. So we are expected to calculate P of x equals to 0 by substituting in the formula here. We will get 1 by 3. So the probability of families, one family getting five five girls as their 5 children is 1 by 32. For 800 families, we just have to multiply it with 800. We will get 25. So 25 families have only girl as their children, and getting values and getting the answer for two or 3 points, that is P of x equals to 2 plus P of x equals to 3. Finally, we will get by substituting the values in the formula, right? And that's it for binomial distribution problems. We will go into the Poisson distribution next. First of all, if you want to know about Poisson distribution, it is also a discrete random variable distribution in which the binomial distribution is mostly used. It is the evaluated form of binomial distribution because in binomial distribution we will calculate the closed values, but here the value of n is large. Here the value of n is large, say 30, and value of p is considerably low when compared to n. So if we want to calculate the binomial distribution for such functions, we use the Poisson distribution as an approximation for binomial distribution. Here, if we want, if it is the probability function for binomial distribution, where R is the number of success chances out of n, is the formula for P of probability calculating in Poisson distribution and E power x formula. If we want to calculate the mean of the Poisson distribution, it is the formula. And for standard deviation, it is here the mean and variance will be same because the QP is as the we are calculating the binomial distribution, but the P is very low and we format it to Poisson distribution. So Q value will be neglected here. So variance and mean it would be same, and it is the standard deviation. We will go depth into the questions next. Here we're going to calculate the, let me, here we're going to calculate the Poisson distribution for a function. For the Rayfield's sum, in which 2% are defective. And we have to calculate the Poisson distribution for at least one defective, exactly 7 defective, and the sample of 100, given that n is 100, right? So uh, uh, chances of success would be denoted by small p, and it is given by 2 by 100, and it is 0.02. In every Poisson distribution function calculation, we need mean value. So mean will be calculated like this, and we will get the mean is 2 here. So for after calculating the mean, we are just dive into the calculation of at least one defective, at least one defective. For at least one defective, we only have to calculate 1 minus 0 defective, right? That's why 1 minus p of x equals to 0. By plugging the values in the function, we will get the value of 0.8646. That's the probability we wanted here. Next, probability of calculating exactly 7 defectives in the rifles and directly substituting the values from the function p of x equals to 7. So finally, we will get this value. And for calculating the probability for the for at least 2 defective, for at least 3 defective, and 4 defective, and so on 7 defective. By plugging the values here, we will get the value of 0.59 for 112. These are the problems on probability. These are the problems on Poisson and the binomial distribution. Thank you.